Let's do some triangle basics, shall we? All angles in a triangle add to 180 degrees. So if I want to find the measure of this little buddy right there, I can just call that x, and I know that I can add 76 and I can add 58, and all of that's going to get me 180. So that means that I can just do some subtraction. I can minus 76 and 58. I'm going to do that in a calculator because I don't want to do it in my head. 180 minus 76 minus 58, and I get 46 degrees. Isn't that nice? I do the same thing over yonder in part B, where I can add everything together. Now equals 180. This time I have some combining of like terms that I can do. So I have x plus x, so I can do 2x, 70 plus 56 plus 66. It's 192. Do some subtraction. 2x equals negative 12, and by dividing by 2, I get x equals negative 6. But the question has asked me to find the measure, ooh, wow, the measure of angle A. So I can just plug that in for angle A. So I have negative 6 plus 66, and I get 60 degrees. Lovely. Let's review isosceles and equilateral triangles, shall we? I'm going to start with equilateral because it's easier to write. Let's see. All sides are congruent. And all angles are congruent. And they are going to be 60 degrees each. I can come down on part A. I'm asked for x. Well, if I see these little markings, that shows me all sides are congruent. So I know that x is going to be 60 degrees. Another one that has that, part E down here. Measure of angle 2 equals x plus 69, and we're supposed to find x. Well, I see it's equilateral because it has these markings on the side showing that they are all congruent. So if every angle is 60, that means that x plus 69 has to equal 60, and I can subtract 69, and I get x equals 9. Part F is also an equilateral triangle because this shows me that all of the angles are congruent, which tells me that all the sides have to be congruent, which that means 2x minus 7 needs to equal 9. So those can be congruent. X equals 8. Cool. Equilateral triangles. Well, if I go to isosceles triangles, the characteristic here, two sides are congruent, and two angles are congruent. We don't necessarily have a set measure for that, but specifically I should say the two base angles are congruent. Yeah, we're going to pretend that looks like congruent. Anyway, because notice the angle that's formed by the two sides, the two congruent sides, there we go. The angle there is not the one that's congruent. It's the other two stemming away from that. So if I come to part B, here are my two, wow, just zooming in. Here are my two congruent sides, which means that these two angles are going to be the same. Well, I know that all triangles add to 180, so it's going to be x. So I know 2x plus 30 is going to equal 180. I can subtract 30 from both sides, and I get that 2x is 150. And if I divide both sides by 2, I'm going to get x equals 75. For part C, same thing, where here are my two congruent sides, so that means these two angles are going to be congruent. So that means that here's 46, So I can say that 46 plus 46 plus x equals 180. Combine like terms and then subtract. Let's see, I don't want to do it in my head, so I'm not going to. And because these are my two base angles, that means those two sides are congruent, so that means x equals 11. Hopefully this is review for you, because it should be. All right, let's talk about the triangle inequality. Here's what you need to know. I'm gonna demonstrate this through a little drawing over here. So let's say I have a side length of 5. And now I'm going to do a side length of 3 and 2. All right, notice that these lines overlap each other. If I was to move this blue and this purple line away from the green line, they would not be connected anymore. I mean, technically they're not connected now, but bam, now they're connected. The point is, if I want 3 side lengths that are going to make a triangle, then the sum of the shorter 2 needs to be bigger than this guy. Excuse me, that little bud. All right, so the sum of the 2 smaller sides must be greater than the length of the largest side. So I can come for number 3 here. My smaller 2 sides are 4 and 10. 4 plus 10 is greater than 12. So yes, we can have a triangle. The next side, 12 plus 8 is equal to 20. 20 is less than 22. So that's going to be no. The reason I'm writing this all out is because the instructions do say to justify your answer. Writing these inequalities like this counts as justifying your answer. And I could go through and do this for the rest of them. I think we get the point. I'll do part E. 9 plus 3 equals 12. 12 equals 12. And it has to be greater than that largest side. So it's going to be a no. Oops. Okay, side angle inequality. The shortest side of the triangle is always opposite the smallest angle. And the longest side of the triangle is always opposite the largest angle. Think of having like a door, and there's a ribbon between the frame of the door and the handle. When you open that door, the wider it gets, the longer that ribbon is going to be. But the more narrow the opening of your door is, the shorter that ribbon is going to be. So if we were to order the sides from shortest to longest for each of these, well, my shortest side is across from my smallest angle. Here's my smallest angle, so it is across from side TU. And then my next angle from there is going to be 60, which is across from ST. And then my biggest side is across from the biggest angle, which is across from SU. Sometimes you might have some angles that are congruent, and that's okay. Here's how we notate that. Because there's a 50 and there's another 50, we would just say that KM, wow, let's try that again. All right, KM is congruent to KL, and then we'll do a comma, and then we'll do that biggest side of LM. Now I can order the angles using that same idea. So with my angles, here is my shortest side, which means it's going to go with my smallest angle, so that's going to be angle D. And now my next one, clearly don't have a rhyme or reason to this color coding. It is fine. Great. And I think that's okay to just do that one example. Well, let's do another since we're in their neighborhood, sure. Smallest, angle A. Next, wow, I totally missed for the record. So let's try that again. It was a sign, I was supposed to use a different color. 22, there we go. Angle B. And that leaves my longest side with angle C. All right. Okay, we're gonna review some parallel lines cut by transversals because it's gonna help us later in the unit. So I'm gonna start, for all of these, I'm just gonna go ahead and draw my parallel lines. They're going to be cut by what's called a transversal, and we're going to call that line T. I'm going to use these symbols to indicate that those lines are parallel. So I'm going to go ahead and draw that for each of these. Apparently, I should have just typed these in when I made the notes. Oh well, lessons for next time. I'm so close. Okay, we're going to label some angle relationships. Vertical angles. So that's vertical angles are going to be anything across from each other in an X formation. So that would be like, those are vertical angles. Or you could come in with a different color. We have more vertical angles. And those could be the same on the bottom set. I'm just going to show them. I'm actually just going to show them in red. It can be applied throughout. Alternate interior angles would be something like this. Actually, no, I'll do this in purple as well. Alternate meaning they're on alternate sides of the transversal. Interior meaning they are inside the parallel lines. And these are congruent. I also forgot to say that vertical lines are congruent. Alternate exterior, well, they're on alternate sides of the transversal, and they're on the exterior of those parallel lines. So it would be there. Oh, mercy, I'm sorry. Those are also going to be congruent, meaning they have the same measure. Corresponding angles mean they are corresponding spots in the first group and the second group. So that would also be something like, so when they're in the same spot, those are also going to be congruent. Okay, adjacent angles are angles that are right next to each other. So like here and and those are supplementary. Those add to 180 degrees. That's what that means, because they add to be a full line. Same side interior. So they're on the same side and they're on the inside. Those are also going to be supplementary. Okay, so those are the names of all of our relationships. So now we're going to apply them to solve for x. Okay, 6 part A, solve for x. Let's see, this relationship, which one is it? I paused so you could have a Dora the Explorer moment. I hope you appreciated that. I hope you shouted out vertical angles. Vertical angles are congruent, so I know that 10x is going to equal the 9x plus 8. Then I can subtract. We get x equals 8. That's nice. Okay, part B. Ooh, that relationship, that looks like some alternate interior angles. I know alternate interior angles are congruent, so I can also say 6x minus 5 equals 5x plus 5. I'll subtract this 5x, and I'll add that 5. I get x equals 10. Okay, part C. This relationship are same side interior. Which means they are supplementary. That means they add to 180. So I can say x plus 111 plus x plus 81 equals 180. Now I can combine like terms. X plus x is 2x. 111 plus 81 is 192. 2x equals negative 12. Divide by 2. X is negative 6. Part D, I can look at my relationships. They're two angles that are next to each other. So that tells me that they're going to be adjacent angles. Adjacent angles are also supplementary, which means they add to 180. So we can do 6x plus 8 plus 17x plus 11 equals 180. 6 plus 17 is 23. 8 plus 11 is 19. Subtract the 19. I get 161. Divide both sides by 23. And I get 7. And there you go.